So now in this next section, we're going to be solving systems of linear equations using the elimination method. So the elimination method is also called the addition method and sometimes called the subtraction method. So what this does is it eliminates one of the variables and allows us to solve for the other one. So the way that we do this is by adding or subtracting. You can technically subtract as well. We're going to be adding the equations together, so one of the variables cancels. So the steps for this, which won't really make too much sense until we do an example, we're going to rewrite both of the equations. So the x and y term are on the left and the constant is on the right. Then our goal is to add the equations together so one of the variables cancels. So we may need to multiply one equation or both equations by a number. So the sum of the coefficients on a variable equals 0 so that they cancel out. So once you do that and you can add them together, we're going to have an equation remaining where it's going to have one variable in it. So we're going to solve that equation for the remaining variable, and then we're going to substitute that value back into one of the original equations to solve for the other one. So let's do an example here to see what we mean. So let's solve using the addition method. So once again, it's either called the addition method or the elimination method. I'll rewrite it though. Okay, so we have x plus 2y equals 7 and negative x plus y equals 2. Okay, so our goal is to add these together so one of the variables cancel. If we recognize right now, if we add these equations together, the x variable will cancel. So we can write it just like how it's written right there, x plus 2y equals 7. Plus, now we're going to add the second equation to it, and then we can just add down in columns here. So x minus x is 0. X plus negative x is 0, so those cancel, which is the whole point. 2y plus y is 3y, and 7 plus 2 is 9. So now we can just solve this for y because it's one small equation with one variable. So we divide both sides by 3, and we get y equals 3. So we have our y, so now we need to take this and plug it back into one of the original equations to find x. So we can pick whichever one of the two equations we want to solve for x. I'm going to pick that second one. So I'm going to pick negative x, I'll do it right here, negative x plus y equals 2. So plug in 3 for y, negative x plus 3 equals 2. We're going to subtract 3 on both sides, get negative x equals negative 1. Divide both sides by negative 1, and we get x equals 1. So that means the solution for this system is going to be x equals 1 and y equals 3. Okay, let's do several more here. So next one is 3x plus 2y equals 48, and 9x minus 8y equals negative 24. So our goal is to add these equations together so that one of the variables cancel, either x or y. So we have to adjust them because we can't add them together now because they won't cancel one of the variables. So what we can do, if we want to cancel, let's say we want to cancel the x variable, we can multiply this first equation by negative 3, and this is to cancel x, because if we multiply that by negative 3, that'll give us negative 9 on the as the x coefficient, which will cancel with the positive 9 from the other one. So we're going to have 3x plus 2y equals 48. And we're going to multiply this by 3. And that's going to give us negative 3, sorry, multiplying by negative 3. That's going to give us, we're going to multiply every single one of those three terms by it. So negative 9x minus 6y equals negative 144. Okay, so now we're going to add these equations together. So this is going to be plus the second equation. And we're going to add, just like we did, add down the columns with the like terms. Negative 9x plus 9x cancels, which is what we wanted. Negative 6 plus negative 8, we get negative 14y equals negative 168 when we add those constants. Divide both sides by negative 14. We get y equals 12. Okay, so we had to adjust this one by multiplying by a number. So now we're going to plug in y equals 12 into one of the originals to find x. So we can pick which one we want to plug in. I'm going to use that first equation. So we're going to plug into 3x plus 2y equals 48. We're going to plug in a y equals 12. And now we can solve that for x. So this is this step right here. So solving this for x, we're going to get 3x plus 24 equals 48. Subtract 24 on both sides, get 3x equals 24. Divide both sides by 3, gives us x equals 8. So that means the solution to this problem is 8, 12. X equals 8 and y equals 12. Okay, a couple more here. So the next one, 3x equals 8 minus 4y, and 4y equals negative x minus 4. So the first thing to recognize here is that this is not in the correct form yet. We have to get this so the x and y are on the left and the constants on the right. So I'm going to rewrite this. I'm going to rewrite that squiggly bracket. I'm going to add 4y to both sides in the first one, so 3x plus 4y equals 8. And then I'm going to add x to both sides for the second one and get x plus 4y equals negative 4. Okay, so now we want to cancel one of the variables. We have a 4y on both of the, we have a 4 coefficient on both of the y's. So we can multiply one of the equations by negative 1 to cancel the y variable. So it's x plus 4y equals negative 4. And we're multiplying that whole thing times negative 1. So that's going to end up giving us negative x minus 4y equals positive 4. And then we're going to add that to the other equation. So 3x plus 4y equals 8. Add these together. Negative x plus 3x, that gives us 2x. The y terms cancel, and 4 plus the 8 is 12. Divide both sides by 2. We can solve for x by getting x equals 6. So then we're going to take that and plug it back into one of the originals to solve for y. So do that right over here. So we get to pick which equation we want to plug it into. So let's just plug it into, we're trying to find y, so let's use that second one. So we can use 4y equals negative x minus 4. And we're going to plug in x equals 6, so negative 6 minus 4. Solve this for y, we get negative 10 on the right. Divide both sides by 4. We get y equals 10 over 4. Which is y equals negative 5 over 2 after we simplify. So our solution is 6 comma negative 5 over 2. Okay, for the next one. So we'll do one more of these and then we'll get into the two special cases. So for this next one, once again, we have to realize that that's not in the correct form. So for the first equation, we have to subtract 7y to the left. So 2x minus 7y equals negative 17. And then the second equation, we have to add 3x to both sides. So we get 3x plus 5y equals 17. So now if we want to cancel a variable, we have to think about which variable we want to cancel, which will be easier. So we can't just multiply one equation by a number here to get to the other one. We can, but we would have to use a fraction. So we're going to have to adjust both of these equations by multiplying both of them by a number. So let's decide to cancel the x variable because the numbers are smaller. So in order to get the same coefficient on the x, the same coefficient would be 6 or negative 6. That means we're going to have to multiply the first one by negative 3, and we can multiply the second one by positive 2. So that'll give us a negative 6 and a positive 6 on the x for the x coefficients. We chose 6 because it was the least common multiple between 2 and 3. Okay, so to do this for canceling x now, we're going to have over here, I'm just going to rewrite 2x minus 7y equals negative 17. We're multiplying this by negative 3. And then we're going to multiply the second one, 3x plus 5y equals 17. We're going to multiply that by positive 2. So when we do that, on the right hand side here, multiplying that first one by negative 3, by multiplying it to every term, we get negative 6x plus 21y equals negative 51. And then multiplying the second equation by 2, we get 6x plus 10y equals 34. And now we're adding these together. So when we add these together, the x terms cancel, which is what we wanted. 21y plus 10y, that gives us 31y. And whoops, I made a mistake. This should be positive 51 for the coefficient on the first one because it was negative times a negative. So now when we're adding 51 plus 34, that gives us 85. So dividing both sides by 31, I think in simplest form, this is just going to be y equals 85 over 31. So a little bit messier. So to find x, now we plug this y value back into one of the originals and solve for x. Okay, so I'm going to choose that first one because it's already almost solved for x. Do it over here. So it was 2x equals 7y minus 17. So plug in 85 over 31 into y. So it's going to get a little messy. So 7 times 85 gives us 595 over 31 minus 17. Getting a common denominator of 31, that's going to be 595 over 31. 17 becomes 527 over 31, getting a common denominator. So subtracting these gives us a little bit better of a number. It gives us 68 over 31. And now we have to divide both sides by 2. When we divide both sides by 2 here, that's going to give us x equals 68 over 62. So that's 68 divided by 31, all divided by 2. So that's keep, change, flip with dividing fractions. And this simplifies to x equals 34 over 31. So our answer here, our solution, is the coordinate 34 over 31, comma, the y value was 85 over 31. Okay, so for the next one here, so the next two are special cases, so let's see what happens with this one. So we have 2x plus 4y equals 5 and 4x plus 8y equals negative 8. So let's say we want to cancel the x. That means we would have to multiply the first one by negative 2. So when we do that, it's going to be 2x plus 4y equals 5. Multiplying that whole thing times negative 2. And that's going to end up giving us negative 4x minus 8y equals negative 10. And we're going to add this to the other one. So add 4x plus 8y equals negative 9. So we know the x's cancel out. The 8 or the y terms also cancel out. We have negative 8 plus 8. So since they both canceled here, negative 10 plus negative 9 gives us negative 19. So the variables canceled, and this is obviously a false statement. 0 does not equal negative 19. So since the variables canceled and we got a false statement, that means there are no solutions. Okay, so there's no solutions for that one. So what this means is that, if you remember from the previous sections, these are parallel lines, so they never intersect, so they are no solutions. So one more, we have negative y equals negative 3x plus 4, and negative 9x plus 3y equals negative 12. So first we have to get this in the correct form. So the first one, we have to add 3x to both sides, so 3x minus y equals 4. Second one was already good, negative 9x plus 3y equals negative 12. And now we can just decide which variable we want to cancel. So if we want to cancel, let's say we want to cancel the x's again, we would have to multiply this first one by positive 3 to cancel the x. So let's do that over here again. So 3x minus y equals 4. We're going to multiply that whole thing by 3. And that's going to give us 9x minus 3y equals 12. We're going to add that to the second one, which we didn't have to adjust. Negative 9x plus 3y equals negative 12. So adding these together, we know the x terms canceled because that's how we set it up. The y terms also happen to cancel, negative 3y plus 3y. So that's going to give us 0 on the left. And then on the right, 12 plus negative 12, 12 minus 12 is 0. So this time we get 0 equals 0, which is obviously a true statement. So since the variables canceled and we got a true statement, there are infinitely many solutions. Okay, so there are an infinite amount of solutions for this one, so that means that these equations actually end up simplifying to be the same exact line. So if we solve both of them for y and simplify it, they would actually equal the same exact thing. Okay, so that is it for this section.